So today we're going to look at inverse functions. First things first, to find the inverse function of each other, all you're going to do is basically flip the x and y and then solve the equation for y. So this equation right here, f of x, that's just a really fancy way of saying y. It's the same thing. So what we're going to do to find the inverse is to flip our x and y. So x equals 7y plus 4. And then we'll just solve for y. So if you want to solve for y, you're following order of operations backward. So sad meg. So I would subtract first. That would give me x minus 4. I don't have any addition. I don't have any division, but y is being multiplied by 7. So I would divide the 7. So then y would equal x minus 4 over 7. And that would be the inverse function. How they show this quite often is they'll put that f of x in there and it'll have a little negative 1. So that would mean the inverse function of the original equation of y, of the f of x. So if you see the little f with the negative 1, that's just what that means. Okay, for this one, same thing. I'm going to replace or flip the x and y. And then I'm just solving for y. So following sad meg. So I'm going to subtract the 7 over. So x minus 7. Then I'm going to divide the negative 2. So x minus 7 over negative 2. And then to get rid of an exponent, you take a root. So this is a third exponent. So I'm going to take a third root. So then y would equal the third root of x minus 7 over negative 2. Now, quite often on multiple choice answers, they will simplify that negative out of the bottom, just meaning they'll multiply everything by a negative. Sorry, divide everything by a negative. So that's an understood one. 1 divided by a negative is just negative 1, so negative x. Negative 7 divided by negative is positive 7, and then that'll just get the negative out of the bottom. They're the same answer, just the negatives got simplified out. And then this one over here, if you have a large group, again, you're just taking the y and replacing it with the x's, but you have 2 x's this time. Not a big deal. You're just going to put y in both of those spots. And then you'll solve. So when you have big groups like this, remember fractions are just division. So you're going to multiply out the bottom over here. So I've got x times y minus 1, and that'll cancel out the fraction. I'm just going to distribute this out. So xy minus x. And then I want to solve for y. I have 2 y's right now, so I want to get them together. So I'm going to subtract 6y over there. Minus 6y, 6y. And then I'm going to move this x over. So I'm going to add x to that side. Once you've got your y's on the same side, that's just a GCF. So I'm going to take those y's and factor them out. Basically, just bring them out front. Opposite of distributing. And then just like at the beginning where we multiplied this whole group to get it out of the bottom, you can divide this whole group to get it away from your y. So that would be 5 plus x or x plus 5 over x minus 6. And that would be your inverse function. Okay, if they give you 2 functions and they want you to see if they are inverses, these you can check by using the composition of them. Composition, remember, are the Fogg and Goff we talked about a little while ago, where for Fogg, you're going to take G and plug it into F. Or for the second one, you're going to take F and plug it into G. So I'm going to look at fog first. So for fog, I'm going to take 3x plus 5, but instead of x, I'm going to plug the G equation in. So I'm going to take that x out. Ooh, didn't say myself room to write. And I'm going to put the G equation in there. And then we just multiply. If they are inverses, their solution must equal x, and only x. It can't be x squared, it can't be x plus 1, it can't be 3x. It has to just be x, and it has to work for fog and Goff for both compositions. So for these, if I multiply here, because I'm multiplying 3 and it's in the denominator, it's just going to cancel itself out. If you wanted to multiply it out, that is 3x minus 15 on top, but 3 simplifies. 3 divided by 3 is x. 15 divided by 3 is 5. So it just cancels out the 3. That's all I'm doing there. And then we're just simplifying some more. Can't combine anything with x, but negative 5 plus 5 is 0. So that leaves me with an x. So this one works. Then we'll check Goff, where we'll take the G equation, but instead of x, I'm going to plug in the F equation. I'm going to take that x out. And right there, I'm going to put 3x plus 5. And then I just simplify. So on top, I've only got 1x, but I have 5 minus 5. That's 0. And then I've got 3x over 3. Well, 3 divided by 3 is 1, so that simplifies to x, which checks out. So these are inverses. Okay, for B, if I check fog and Goff. So for fog, I'm going to take the F equation, but instead of x, I'm going to plug in the G equation. So that's all x, and then cubed minus 5. Cubed and cubed root, those are opposite, so they cancel. That leaves me with x minus 5 minus 5. And then negative 5 minus 5 is negative 10. That doesn't simplify any further, so that does not leave me with x. So these would not be compositions. You can check Goff if you want to. I'll show you what that would look like. If you plugged in F, negative 5 minus 5 again is negative 10. This cubed and cube root do not cancel because I can't cube root 10 as well. The only reason this one canceled is because the whole group was being cubed, not just a single number. So this doesn't simplify any further, so this doesn't work as well. So if it gives you x, those are inverses. If it does not give you x, if it gives you anything else, they're not inverses. Okay, next thing we're going to look at with this are one-to-one functions. Functions just mean that every, like if you tried the vertical line test, you could draw a line and it only hits the graph in one spot, no matter where you draw that line. So like over here, if I drew a line, it hits the graph 3 times. That's not a function. Now, you also, for one-to-one functions, have to check across as well. Horizontal line test. So for this one, the vertical line test worked. If I draw a line, it only hits once, no matter where I go. If I check the horizontal line test, it only hits once, no matter where I go. So this would be a one-to-one function. For this one, if I draw a vertical line, it only hits once. If I draw a horizontal line, now it hits twice. So this is not a one-to-one function. For C, if I draw a vertical line anywhere, it only hits once. If I draw horizontal lines anywhere, it only hits one time. So that is a function, a one-to-one function. For this one, if I try the vertical line test, it only hits one time for each spot. But if I do the horizontal line test, it's not hitting anywhere up here, but if I draw it on this line, it hits at every single spot. So that is definitely not a one-to-one function. So anytime you have straight lines going either horizontal or vertical, those are never ever one-to-one functions because they hit every single spot there. And then we already talked about this one a little bit. If I did a vertical line, it hits twice here. If I did it over here, it hits 4 times. So definitely not one-to-one, even though if I want to cross, it only hits once. But it didn't pass the vertical line test, and it has to pass both. So this is not a one-to-one function. You can check this out with equations as well. There is a really long way to do this using the inverses, but there is a little bit of shortcut for this. What you're looking for in these are you're looking for even exponents, not odd exponents, and I'll show you this on a graph to show you why, or you're looking for single variable equations. So if it only had an x, or it only had a y, or it only had a, I don't know, single variable equations. So for this one right here, I don't have any even exponents, and I have 2 variables. So this one is a one-to-one function. And I'll show you this on a graph so you can see why. So this is 2x plus 4y equals 5. So if I went across or vertical, it's going to pass the one-to-one test. So that one is definitely a one-to-one function. For the next one, I've got an even exponent. So this is not going to pass the function test. And I'll show you why. When you have an even exponent, it's going to create these parabolas. They may be up and down, they may be horizontal, but it creates these parabolas. And while it does pass a vertical line test, it does not pass horizontally. So that is not a one-to-one function. For this one right here, I don't see any exponents. I have 2 variables. However, I do have a little distributing right here, and you do need to simplify. If I distribute this, y times 8y is 8y squared. Y times 3 is 3y. And then there's no other variables I can combine. There's no like terms. But now I do have an even exponent. So this is not going to pass the one-to-one function test. And I'll show you with the original equation and with the distributed version. So the original equation was this. So again, it's going to create that parabola because when you distribute it, you're getting that even exponent. 12x minus 9. Did I write this right? Oh, I forgot the 8. You're getting that even exponent. This time it's on the y, so it creates a sideways parabola, but it does not pass the vertical line test this time. So it's not a function. On I, you do have an even exponent. So this is not going to pass the vertical line test or the horizontal line test, one or the other. You could FOIL this out. It would give you x squared plus 6x plus 9. Combine your like terms, and that would give you 7. But even at the beginning, I have an even exponent. So this is not going to work. Again, I'll show you this in the graph. So again, it creates that parabola, which this time does not pass the horizontal line test. Okay, on this one right here, I don't have any exponents, but I only have one variable. When I have one variable, y equals 12, that creates this horizontal line. And like we saw on example D, horizontal lines are not going to pass the horizontal line test because it literally hits at every single point. So this is not going to be a one-to-one function. Okay, and then this last one right here, I don't have any exponents, but I only have one variable. So because there's only one variable, this is not going to pass the one-to-one function test. You could combine 4x minus 4x is 0. And then if you solved, add your 5 over, divide your 10, you're just getting 1/2. But it doesn't matter because it's still only one variable. So if I were to plug this in, equals 10x minus 5, this one gives me a vertical line because it's just x values. So that's not going to pass the horizontal line or the vertical line test this time. I didn't have any examples with odd exponents, but if you had an odd exponent, say x to the third, this one does pass. I could draw vertical lines, I could draw horizontal lines, and it passes the line test. But the second you make it an even exponent, it no longer passes the line test. So that's why it's even exponents that matter and not necessarily odds. I can make it 5. That's still going to pass the line test. Now I know it looks horizontal right here, but if you zoom in, it's hard to see, especially when you zoom in, but it is slowly going up and slowly going down. Like I could click on it. You can see the numbers are changing. They're not staying the same. For instance, if I just had x equals 4, the x value right there never, ever, ever changes. It's different. The y's value is changing, but the x is not. So odd exponents are fine. Even exponents are not. And then single variable equations are not. Okay, go try your practice.